Welcome Calculus BC. This is lesson 2.6, increasing, decreasing functions and the first derivative test. Let's begin. So, first derivative test. We use this when we want to figure out where a function is increasing or decreasing and to figure out relative mins and maxes. So we got this procedure for this, and I'll kind of summarize this. You want to find domain restrictions, so usually the function says, hey, only between the domain of like 0 and 5. So it's usually like given to you. And then want to find the critical numbers in that domain. So that's where critical numbers happen where the derivative equals 0 or does not exist, undefined. But so you have to know, all those have to be within the domain. And so you want to figure out, and after you do this, these steps get locate the critical numbers and domain restrictors on the number line. Now we make a table. And then we're going to test intervals in between each table. And then we'll list increasing, decreasing values and identify the relative min and max. So just a reminder, these are what functions are going to look like. Either a function like this, this, or this. And our critical numbers are going to happen like at the tops and bottoms or at numbers like this. So looking at each of those functions I drew, on the left side of this one, we are increasing, and the right side, we are decreasing. This makes this a relative max. You have to have increasing on the left, decreasing on the right. For this function, we are decreasing on the left and increasing on the right, so we call this a relative minimum. And in cases where they're doing the same thing on each side of the critical number, these are neither. These are neither increasing or decreasing. Sometimes we call this monotonic, so it's just always increasing. So yeah, that's why you have to do these tests, and you have to check the intervals and to see if you're actually a relative min or max, or just neither. So let's do some examples lists. Taking this example. So find the intervals in which these functions increase, decreasing, and local extrema point. That means relative mins and maxes. So first thing I'm going to do is I'm going to derive. That's your first thing. So it's going to be 1 minus 2 cosine of x. All right? And you're going to set that derivative to equal 0 or does not exist. In the case of this function, this will never be does not exist. So I'm going to say 0 equals 1 minus 2 cosine of x. And note my domain is from 0 to 2 pi, so basically the unit circle, except at 0. And I want to isolate the whenever you have trig functions, isolate the cosine, subtract 1, so you get negative 1 equals negative 2. Cosine of x, so 1 divided by 2 equals cosine of x. So where's cosine equal 1/2 on the unit circle? Cosine's your x values. The 1/2 happens in the positive, and that is going to be the third spoke right here, and the third spoke down here. And this one's going to be pi over 3, and this one is going to end up being 5 pi over 3. Yeah, I got that. So x equals pi over 3 and 5 pi over 3. I have two critical numbers. All right, so I'm going to make my table. And this is what we did last year. I kind of like laying this out. So each one of those critical numbers is like one of call them spokes, because they're not really the columns, kind of they're in between. But pi over 3 for this one, and 5 pi over 3 for this one. So you're going to check values. You want to check what the slope is in between in each of these. So between the critical numbers, everything is going to either be increasing or decreasing. That's the point. So right here, it's all the same. Right here, it's all the same. And right here, it's all the same. So I'm going to pick some test values, and we're going to plug them into the derivative. So let's pick a test value. I just kind of like a number easy in between these two. I'm going to pick the value of pi in between those two because I think that'll be easy. I'm going to pick 5 pi over 3. I'm going to pick 7 pi over 4. And let's just do, 1 pi over 4, just to be consistent. But I could pick anything that's smaller than pi over 3, but bigger than 0. So you're going to check y prime, the derivative is going to be, when you plug pi over 4, 1 minus 2 cosine of pi over 4. So that's going to be, and all you care is if it's positive or negative. 1 minus 2, what's cosine of pi over 4? That's going to be square root of 2 over 2. So that's 1 minus square root of 2. That is going to be a negative number because square root of 2 is bigger than 1. All right, and if you plug in pi, so it's y prime equals 1 minus 2 cosine of pi. Cosine of pi is going to be negative 1, so 1 minus negative 1, which would be 1 plus 1, which is 2, which is positive. And the last one, y prime equals 1 minus 2 cosine of 7 pi over 4. That's going to be 1 minus 2 cosine, that's going to be square root of 2 over 2. And so 1 minus square root of 2, which is also negative. So we have over here, we are decreasing slope, we are increasing slope, and decreasing slope. Okay, so we want to know, first question, where the intervals are it's increasing and decreasing. I'm going to put some work over here. So I'm going to say it's increasing on these intervals. We're going to say, I'm going to go from nope, not negative infinity, because it's going from 0 to pi over 3. And it's also increasing, or not increasing, this is where it's decreasing. Decreasing. And it's also increasing from 7 pi over 4, not 7 pi over 4. It's our critical number. So 5 pi over 3 to 2 pi. And I'm going to say it's decreasing on this interval in the middle, which is going to be pi over 3 to 5 pi over 3. Do I have to do curved or brackets? I think I could have done brackets, but at the end points they should have been curved. I don't know if it matters. Yeah. All right, so where it's the local extreme, a relative min and max. And what I like drawing is just drawing the picture up here. Okay, decreasing goes down, and then increasing goes up, and decreasing goes down. So at these critical number right here, if you draw the picture, you see that it's kind of at the bottom of the valley. So I'm going to say there's a relative max and relative min. We have a relative max right here, which is going to be at x equals 5 pi over 3, and a relative min when x equals pi over 3. All right, so a lot of work on that one, but you saw the steps. Just draw this table. You're determining increasing and decreasing between each of those intervals, and that helps you identify where relative mins and maxes are. All right, we'll do this in class. Don't need more examples. And that's it. We're done.